Lesson 2 is on understanding theoretical probability. In the word theoretical, you might see the word theory, which has to do like what we think is going to happen maybe. So like kind of like in science you've talked about a hypothesis. It's kind of a similar idea to that. So if you look at this on 361, solve and discuss it. Betty and Carl will conduct an experiment. They will flip a coin 100 times and record the result of each flip. What should they expect the results of their experiment to be? Justify your answer. So on a coin we have two sides, heads and tails. So what we're going to expect is that we'll get about half the times will be heads, half the times will be tails. Now, that's theoretical, okay? Theoretical actually is that exactly half the time they're going to be heads and half the time they're going to be tails, okay? That may not happen, but it should be something close to that, or we've got a rigged coin here. But again, theoretically, half the time heads, half the time tails. So theoretical probability, the book has it highlighted here for us, but they don't really give us a great definition maybe. So here it is at the top. Theoretical probability, it's like how likely it is something will happen in theory. It's how likely something is going to happen. So if we look at example 1, Talia and Yoshi design a game for the school fair. Contestants spin the pointer and win a prize if it lands on either of the two red sections. How can Talia and Yoshi determine how many people are likely to be winners if 500 people play their game? So 500 people play the game and they win a prize if it lands on the red sections, which they've made pretty simple here by putting the word win on the red sections. Makes it kind of easy for us to tell that. Okay, so if we look at this, first of all we want to figure out what our probability is. Remember, probability is going to be a number like a fraction telling us what our chance is of winning the game here. So if we look at this, how many red sections do we have?
2.
How many total sections do we have?
16.
Okay, so the chance of us winning would be 2 out of 16. Now, that would be our theoretical probability. Like we talked about yesterday, we can label like this. If you see a P and then something in parentheses, that means probability of getting red in this case, or probability of winning, we could say would be the same thing. So we have 2 red sections out of 16, 2/16, which reduces to 1/8. So we have a 1/8, or if you divide, you'll get 0.125, which means 12.5% chance of winning. So is that likely? By our standards yesterday, we would say it's not likely that we're going to win, right? Less than 50%. Okay? So the next thing is we want to figure out how many winners, okay? Let's say we have prizes are going to be stuffed animals. Well, 2 things. First of all, we don't obviously want to run out of prizes and say, well, sorry, nobody else can play because I don't have any prizes left. By the same token, though, you know, if we have stuffed animal prizes, we don't want to have like 200 stuffed animals left when we're done, right? Okay, so this is why they're maybe doing this, figuring out, you know, about how many stuffed animals am I going to need. So our probability was 1/8. What we can do is just do a proportion here. So 1/8 is something out of 500. What the book's doing, they're saying they're dividing by 500, so they multiplied by 500 on both sides, and then they got 62.5. Another thing we could do, if you remember with proportions, we can look for patterns. So what I would do is, I like the pattern here with the 1 and the 8. I don't really see a great pattern just looking at it with the 8 and 500. Remember, when you do a pattern, it has to go towards the variable, and it has to be multiplying or dividing. So in this case, we would be going from the 8 to the 1, which would mean we would be doing what? Dividing by 8. Good. 8 divided by 8 is 1. So we do 500 divided by 8. And if you do that, you'll get 62.5 or 62.5. So that means we're expecting 62.5 people to win the game. So I guess we will be, somebody's going to be winning half of a stuffed animal. Now, in a case like that, you would be rounding this off. So 62.5, you could either say 62 or 63, okay? To be safe, we might say 63, and then maybe we'll buy some extra stuffed animals just to make sure we don't run out, okay? So if we look at the try it, we have a similar situation here. Talia and Yoshi redesigned their spinner to have 14 sections instead of 16 sections. So now 14 instead of 16. Would they likely have more or fewer winners, and explain why? And they've got a picture here for us. So if you'll notice, we still have 2 winning sections. It's just that we have a total of 14 instead of 16 sections. So in this case, still with the 2 winning sections, 2 out of 14, or 1/7 chance of winning. Remember before we had a 1/8 chance of winning. So think about like this: if there were 8 people and you were one of the 8 people that might win, or you were 1 out of 7 people that might win, 1 out of 7 is obviously a bigger chance that you're going to win. Still not likely, but a better chance. So we would say that we would have a higher chance of winning because one way of looking at it, I mean, we have the same amount of winning sections, but we have fewer non-winning sections, would be a way to think about that. Example 2, Archie plays a word board game, sometimes known as Scrabble. He places 98 lettered tiles and 2 blank tiles in a bag. Players will draw tiles from the bag one at a time without looking. What is the probability that the first tile drawn will be a blank tile labeled with a letter, a vowel, a consonant? So we're answering 4 different questions here. So if you look at the tiles, with the tiles we have 2 tiles that are blank out of 100. And they told us they told us 98 lettered and 2 blank tiles, so that's an easy way of counting 100. Or you can say there's 10 across, 10 down, 10 times 10 is 100, rather than counting them all. So the blank, that'd be 2 out of 100, which is a 1 out of 50 chance. The letters, all the other ones are letters. That's 98 out of 100, which is 49 fiftieths. Okay, so pretty likely that we'll get a letter. Not very likely we'll get a blank one. The vowels, we'll trust that they counted those correctly. 42 of them. So 42 out of 100, or 21 fiftieths that are vowels. And then consonants would be the other ones. So the letters, there were 98 letters. So a way you could figure that out, if you are confident you have the right number of vowels, you could take 98 minus 42 would give us that 56. So 56 hundredths that are consonants, and that's 28 fiftieths. Oh, we could reduce that further. That would be 14 25ths. Usually we want to reduce as much as we can. Okay? So look at example 3. Joaquin also designs a game for the school fair. Contestants roll 2 number cubes, or dice, at the same time. If the sum of the numbers of the 2 cubes is 7, the player wins. So the sum, if the sum is 7, the player wins. About how many winners should they expect if 500 contestants play his game? So similar idea here. What they're doing here, they've got a table. This is kind of like a multiplication table. You guys familiar with that idea? Only this is an addition table. Okay? So for example, in the top left corner, 1 plus 1 is 2. Here we've got 2 plus 1 is 3. Or up here, 1 plus 2 is 3. Okay? Anyway, you can see that. The deal is that we need a sum of 7 in order to win. You might notice a pattern actually is that we have diagonals. So only one way to get a 2 would be 1 and a 1. Here's the 3s, here's 4s, here's 5s, here's 6s. Okay, 7s, 8s, 9s, 10s, 11s, 12. Okay, so they end up going in diagonals in this chart. It's kind of interesting. So if you'll notice, the 7s, that's our biggest diagonal. So 7 is actually the most common number that you could roll when you're rolling 2 dice. Okay, so the deal is then, if you count them up, there are 6 7s out of 36. So 6 out of 36. That reduces down to 1/6. We could reduce those both by 6. So we've got a 1 out of 6 chance. Not very likely, we could say, right? But it's our best chance out of getting anything. So 1 out of 6 chance of getting a 7. And then we could figure out for 500 people how many we would expect to win. Once again, I like this pattern here, kind of. Going from 6 to 1 would be dividing by 6. So we do 500 divided by 6. This time we get 83.3 repeating, which is 83 1/3 people are going to win this time. Okay, we'll round it off once again, and so we'll say about 83 people that would win. So key concept, just recapping how we find the probability, which we've already talked about, and how we can do ratios or proportions to figure out predictions of how many people would win. Do you know how? Number 4, they want us to find the probability of rolling a 4 if we're rolling a 6-sided number cube labeled 1 to 6. So how many 4s would we have on that number cube? 1 out of 6. Can't reduce, that's it. That's all we got to do there. Okay? Number 5, probability of rolling an odd number. What odd numbers would we have? 5, 1, and 3. Is that all of them? Okay, so how many odd numbers would that be? 3 out of 6, and that's the same as 1/2. Good. 3/6 is 1/2, or 50% chance of rolling an odd number. Okay? And then number 6, if Monique rolls the number cube 12 times, how many times would she expect a number greater than 4 to be rolled? So greater than 4 would be what options? 5 and 6, okay? So 5 and 6, how many numbers is that? 2 out of 6, okay? We're trying to find a number out of 12. Normally I would go ahead and reduce that and say we got a 1/3 chance. In this case, what we could actually do would be multiply them both by 2, and we could say 4 out of 12. Okay? If you don't see to do that, again, you could reduce it down. It would reduce to 1/3, and then you would just figure out, how many out of 12. Find your pattern, and you'll get 4 that way also.